All right, good morning, fifth graders. We're going to go ahead and take the long division that we worked on yesterday one step further, and we're going to take a look at long division with remainders, which is a very, very simple process for the way that we're going to do it today, but moving forward, when we get back from Thanksgiving break, we'll look at how we can represent our remainders as fractions as well as decimals. And today, we'll just go ahead and use our remainder R. So, let's review. Recall that division is the act of breaking up a quantity, and that quantity that's being broken up is called the dividend, into equal parts, and those equal parts are the divisor. We call the answer the quotient. Now, as you notice, we've been hearing those words a lot. That's because they're very important terms that you will certainly need to know for your unit test and just for math moving forward. So sometimes our divisor does not go into our dividend evenly. Now, just because it doesn't go in evenly doesn't mean that it can't be done. No, not at all. We can still divide things even if it doesn't go in perfectly. And we'll look at a bunch of examples. But off the top of my head, for instance, if I have $75 and I want to divide that amongst two people, 75 is not divisible by 2, which means that 2 doesn't go into it evenly. Does that mean that I cannot break up the $75 amongst two people? Absolutely not. You can totally do that. It just means that you'll have $1 left over, and then you can take that $1 and split it up amongst the two people, and each person would get 50 cents or less than one whole thing, one whole dollar. So we will have something that's left over, and again, we call that leftover the remainder. Okay, so let's take a look at a model just so we can get a visual of what's happening. Let's take 14, that's our dividend, and divide that by 4, which is our divisor. So let's create an array, 6, 7 by 2. Okay, and let's go ahead and break that up into groups of 4. 1 group, 2 groups, 3 groups. Excuse me. So 4 does fit into 14. 3 whole times, but we have 2 left over with 2 remaining. So we are going to use the letter R to represent our remainder. So for this, I would say that 14 divided by 4 is 3 remainder 2. 3R2. 3 remainder 2. So let's go ahead and take a look at a few more examples. Oop, I missed a blank. After you've divided, so when do we know, when we do long division, how do we know what our remainder is going to be? Well, after you divided the last digit, the answer to that last subtraction problem becomes your remainder. So let's do an example together. 351 divided by 7. Now, I'm a big fan of creating columns so we can keep our work nice and neat and organized. And also, I want to point out, if you have 3 digits in your dividend, you need to have 3 digits in your answer, and that may include a 0 placeholder. So we're going to start in our largest place value, and we ask ourselves, how many times does 7 go into 3? Well, it goes in 0 full times. Now, again, we talked in the last video about how we can go ahead and multiply the 7 by the 0, and we get 0, and we subtract, we get 3, and we bring down the 5. So our next number would be 35. Well, look, you got 35 right there. If you have a 0, you don't have to do the subtraction. You can just go ahead and take a look at that next number, extend it to the next digit. How many times does 7 go into 35? Well, it goes in 5 whole times. We subtract 35. We get 0. We bring down the 1. Excuse me. How many times does 7 go into 1? It goes in 0 full times. Now, I could subtract 0, and I get 1. Sorry, been feeling a little under the weather this week. Bear with me. So this is the answer to the last subtraction problem, which means it is my remainder. So I will say 50 remainder 1. Pardon me. Let's take a look at another example. 8,372 divided by 3. This is my dividend, so that will go inside of the long division symbol. I'm going to space them out just so that I'm not cluttered, so I don't make any mistakes. Got plenty of room. Let's use it. Let's begin. We're going to go ahead and look at this biggest digit over here. 3 goes into 8 2 whole times. 3 times 2 is 6. I subtract. 2 is left over. I bring down the 3. 3 goes into 23. 7 whole times. 3 times 7 is 21. I subtract. I get 2. Bring down the 7. 3 goes into 27. 9 whole times. I subtract 27. I get 0. I bring down the 2. 3 goes into 2. 0 whole times. Now again, I can subtract 0, but I'm still just going to be left with the 2. So I know that this is my remainder. Oops, sorry. So I would say, so this answer, this quotient is 2,790 remainder 2. And that would be our final answer. And let's look at one more real world problem. Let's apply what we just learned. Anthony has 103 starbursts. If Anthony gives equal shares, equal shares, that immediately makes me think about division. If Anthony gives equal shares of starburst to 8 friends, and he eats what's left over, I'm thinking remainder, how many starbursts does each person eat? So we're going to go ahead and split up the 103 starbursts amongst the 8 friends, and then Anthony will take what's left over. So I'm going to create my columns. 8 goes into 0, or excuse me, 1 0 times. Now I'm going to look at this as 10. 8 goes into 10 one time. I subtract 10. Whoops, sorry. 8. I apologize, I'm getting ahead of myself. 1 times 8 is 8. I subtract 8 there. 10 minus 8 is 2. I bring down the 3. 8 goes into 23 2 whole times. I subtract 16. The difference between those two is 7. This is my remainder. So this is my remainder right here, the answer to the last subtraction problem. So we have 12 remainder 7. We can conclude that each friend receives 12 pieces, and Anthony gets the remainder. Gets 7 pieces, because that was the remainder, what was left over. That's a very nice application of having remainders, but they still have meaning. That these 7 pieces, even though it was a remainder, doesn't mean that it's not worth anything. It absolutely is still worth something. Like I said, moving forward, we're going to go ahead and start expressing our remainder as fractions as well as decimals.